Here's something that should keep you up at night, or maybe help you fall asleep, depending on how you look at it. Our species, Homo sapiens, the ones who built skyscrapers and sent rockets to Mars, who invented the internet and split the atom, we've been around for about 300,000 years. That sounds like a long time. It's not. There was another human species. Not an ape. Not a distant ancestor we can barely recognize. An actual human. Homo erectus. Upright man. And they survived for nearly 2 million years. Let me say that again because the numbers are so large they almost lose meaning. If you tried to fit the entire history of Homo sapiens into the lifespan of Homo erectus, we'd be like the last hour of a week-long event. Think about it this way. Homo erectus watched the world change in ways we can barely imagine. They survived ice ages that buried continents under miles of ice. They endured volcanic eruptions that changed global climates. They witnessed the birth and extinction of countless other species. They spread from Africa to Asia, to Indonesia, to China, to the forests and savannas and highlands, adapting to environments so different from where they started that it's astonishing they remained recognizably the same species. And through all of that, through climate catastrophes and predators and competition with other hominins, through droughts and floods and everything that Earth could throw at them, they survived. For 2 million years. Generation after generation after generation, numbering in the billions, each one finding food, avoiding danger, reproducing, passing something on to the next generation. We've been here 300,000 years. In evolutionary terms, we just arrived at the party. And yeah, we've done impressive things in that time. We've gone from small bands of hunter-gatherers in Africa to a global population of 8 billion people. We've transformed the planet in ways that will be visible in the geological record millions of years from now. We've created technologies that would seem like magic to our ancestors from just a few hundred years ago, let alone 300,000 years ago. But here's what should humble us. We almost didn't make it. Multiple times in our short history, Homo sapiens came within a whisper of extinction. Around 900,000 to 800,000 years ago, before we were even fully Homo sapiens, our population crashed to around 1,300 individuals. 1,300. That's fewer people than attend a medium-sized high school. We were one bad winter, one disease outbreak, one streak of bad luck away from vanishing completely. And if we had, the universe wouldn't have cared. Other species would have risen and fallen. Earth would have kept spinning. The fact that we're here at all is partly skill, partly adaptation, but also partly absurd luck. Homo erectus didn't have that fragility. Or at least, they recovered from it better. They endured. They persisted. They were the definition of evolutionary success in terms of longevity. When they finally did go extinct, around 117,000 years ago, in their last refuge on the island of Java, they'd already had a run that makes most species look like brief experiments. Compare that to us. 300,000 years. We're infants in evolutionary terms. Babies. We haven't even come close to proving we can match Homo erectus's endurance record. And considering the rate at which we're changing our planet, the way we're burning through resources, altering the climate, driving other species to extinction, it's an open question whether we'll make it another 300,000 years, let alone 2 million. This isn't meant to be depressing. Well, maybe a little. But mostly it's meant to give perspective. Because when we talk about human success, when we celebrate our accomplishments, when we assume that Homo sapiens is the pinnacle of human evolution, we need to remember that success can be measured in different ways. Homo erectus measured their success in survival, in persistence, in the ability to keep going when the world changed around them, to adapt without losing who they fundamentally were. They weren't building cities or writing symphonies, but they were doing something we haven't proven we can do yet. They were lasting. The ace they were. So tonight, as you drift off to sleep, think about those 2 million years. Think about the countless generations of Homo erectus, living their lives, raising their children, surviving in ways we're only beginning to understand. How many sunrises, how many storms, how many moments of fear and joy and ordinary existence, stretching back so far into deep time that it makes our 300,000 years look like a footnote. And then think about us. about how recent we are, how untested, how uncertain our future really is. Because if there's one thing the story of Homo erectus teaches us, it's that success isn't about how high you fly. It's about how long you can keep flying, and we've only just left the ground. Before we go further, maybe hit subscribe if you're enjoying this journey through deep time. Drop a comment about where you are and what time it is right now. Singapore at 2 a.m? Stockholm at sunset? It's wild how we're all here together, learning about ancestors who would never have imagined a world where their descendants could share thoughts instantaneously across the entire planet. But let's put these numbers into perspective in a way that really makes them hit home. Imagine each 1,000 years as a single day. Under this scale, Homo erectus lived for 5.5 years. Nearly 6 years of continuous existence, day after day after day. Homo sapiens, on our compressed timeline, have been around for just over 4 months. We're still in our first year of existence. We haven't even seen our first birthday yet on this scale. Or think of it geologically. When Homo erectus first appeared, around 2 million years ago, Earth was in the middle of the Pleistocene epoch. This was a world of megafauna, giant mammals that would seem alien to us today. Mammoths and saber-toothed cats, giant ground sloths the size of elephants, terror birds in South America that stood 10 feet tall. Homo erectus watched many of these species evolve, thrive, and go extinct. They outlasted so many creatures that once seemed permanent fixtures of the landscape. By the time the last Homo erectus died on Java around 117,000 years ago, the world had transformed multiple times. Continents had drifted measurably, new species had evolved and vanished. The climate had swung from Ice Age to interglacial period and back again dozens of times. And through all of it, Homo erectus adapted just enough to keep surviving, without changing so much that they became something else entirely. That's the real miracle of their story. Not that they stayed exactly the same for 2 million years, they didn't, but that they maintained a recognizable identity across an almost incomprehensible span of time. The Homo erectus who lived in East Africa 2 million years ago would have looked different from their descendants in Java 1 million years later. Different brain sizes, different tool technologies, different adaptations to local environments, but they were still fundamentally the same species. Still Erectus. Still survivors. We don't know if we can do that. We don't know if Homo sapiens has that kind of endurance built into our DNA. Because the thing about longevity as a species is that it requires a delicate balance. You need to be flexible enough to adapt when conditions change. But you also need to be stable enough that you don't fragment into multiple species or change so rapidly that you're no longer recognizable as what you started out being. Homo erectus found that balance. For 2 million years, they walked the tightrope between adaptation and stability. They spread across 3 continents, developing regional variations while maintaining enough genetic continuity that they remained one species. They created increasingly sophisticated tools without revolutionizing their entire way of life. They adapted their diets to local resources without losing their fundamental identity as hunters and gatherers. And maybe most remarkably, they did all of this without the technologies we consider essential. No agriculture, no cities, no writing, no domesticated animals beyond possibly dogs, and even that's debated. They survived on their wits, their tools, their ability to work together, and their capacity to learn from their environment. For 2 million years. That's not just survival, that's mastery. So when we look at ourselves, at our 300,000 years and change, we need to ask honestly whether we're on the same trajectory. Are we the kind of species that can last 2 million years? Or are we burning too bright, changing too fast, pushing too hard against the limits of what our planet can sustain? Are we the next great survivor? Or are we the flash in the pan that happens to be conscious enough to document our own story? These are the questions that should haunt us as we explore the tale of Homo erectus, because their story isn't just about them. It's about the difference between explosive dominance and quiet persistence. It's about whether the goal is to transform the world or to live with it. And it's about whether we, Homo sapiens, the supposedly wise man, are wise enough to learn from our ancient relatives before it's too late. Consider what 2 million years actually means in terms of human generations. If we estimate an average generation length of around 25 years for Homo erectus, that's 80,000 generations, 80,000 cycles of birth, growth, reproduction, and death. 80,000 opportunities for evolution to select for traits that enhanced survival. 80,000 generations of accumulated wisdom passed down through observation and teaching, building on everything that came before. Compare that to us. At 25 years per generation, Homo sapiens has been around for about 12,000 generations. That sounds like a lot until you realize it's only 15% of Erectus's run. We're newcomers. We're still in our trial period. Evolution hasn't had nearly enough time to test whether our particular combination of traits, our big brains and complex societies and rapid innovation, actually works over the long haul. And here's something else to consider. For most of those 80,000 generations, Homo erectus lived in a world that was genuinely wild. A world where humans were just one species among many, not particularly dominant, not transforming ecosystems, just surviving as best they could. Predators hunted them, diseases killed them, climate disasters wiped out populations. They were tested constantly, and they passed every test for 2 million years. We, on the other hand, have spent most of our 12,000 generations in that same wild state. It's only in the last few hundred generations, since agriculture, that we've started to dominate our environment. And it's only in the last 10 generations, since industrialization, that we've had the power to fundamentally alter planetary systems. And we don't yet know if we can handle it without destroying ourselves. This isn't pessimism, it's realism. Every species that has ever dominated its environment has either adapted to live sustainably within it or gone extinct. There are no exceptions. The dinosaurs dominated for over 100 million years and still went extinct when conditions changed. Dominant species are often the most vulnerable because they're overspecialized, too dependent on specific conditions, too inflexible when those conditions shift. Homo erectus never became dominant in that sense. They were successful, widespread, numerous enough to persist, but they remained part of the ecosystem rather than standing apart from it. They adapted to their environment rather than forcing their environment to adapt to them. And that strategy worked for an almost incomprehensibly long time. Whether our strategy of environmental dominance and rapid transformation will work for even a fraction of that time remains to be seen. We're conducting an experiment with ourselves as the subjects, and the results won't be clear for thousands, maybe millions of years. That's the sobering reality we need to carry with us as we explore this story. Let's continue. If you saw a Homo erectus walking down the street, you'd do a double take, but you might not immediately realize they weren't human in the modern sense. Not quite right, but close enough to fool you for a moment. That's because Homo erectus was the first of our relatives to develop what we'd recognize as a human body plan. And that's no small achievement. Before Erectus, our ancestors were strange creatures by modern standards. Australopithecus, the famous Lucy and her kind, were bipedal, yes, walking upright on 2 legs. But they still had long arms relative to their legs, bodies built for climbing trees as much as walking on the ground. They were transitional, caught between the forest canopy and the open savanna. Homo habilis, the earliest member of our genus, was slightly more human-like, with a bigger brain and better tools, but still retained those long ape-like arms. Homo erectus changed all that. When they appeared around 2 million years ago in East Africa, they brought a body plan that would define all future humans. Longer legs, shorter arms, a narrow pelvis designed for efficient long-distance walking, a taller stature ranging from 4 feet 9 inches to over 6 feet, with most individuals somewhere in the middle. This was a body built for covering ground, for migration, for endurance rather than power. Look at the skeleton known as Turkana boy, discovered in Kenya and dating to about 1.6 million years ago. This is one of the most complete Homo erectus fossils ever found, a juvenile who died around age 8 to 11. Even at that young age, his body proportions were essentially modern: long limbs, narrow torso. If you dressed him in modern clothes and put him on a playground, From behind, you might think he was just another kid, until you saw his face, because that's where Homo erectus still looked distinctly not like us. The skull was lower and longer than ours. Thick brow ridges protruded over the eyes, giving them a pronounced, almost Neanderthal-like appearance. The face was larger, more prognathic, jutting forward with a less vertical profile than modern humans. Behind that face was a brain that varied considerably across their 2-million-year history, but averaged around 1,000 cubic centimeters. That's about 70% the size of a modern human brain. But here's the crucial point. That brain was still significantly larger than their predecessors. Homo habilis had brains around 600 to 800 cubic centimeters. Australopithecus was even smaller, around 400 to 500. Homo erectus represented a massive jump in brain size, and with that jump came new capabilities. Better problem solving, more sophisticated tool use, enhanced social complexity, the cognitive foundation for everything that would follow, and they put those brains to work immediately. Homo erectus is associated with the Acheulean stone tool industry, a technological revolution that lasted over 1 million years. These weren't the simple choppers and flakes of earlier hominins. These were hand axes, bifacial tools, carefully shaped on both sides into symmetrical, teardrop forms. Making an Acheulean hand axe required planning, skill, and an ability to visualize the finished tool before starting to work the stone. Think about what that means cognitively. You pick up a rock. You have to imagine the shape hiding inside it. You have to plan the sequence of strikes that will reveal that shape. You have to adjust your technique as you work, compensating for flaws in the stone, modifying your approach when things don't go exactly as planned. This is abstract thought. This is humans imagining something that doesn't exist yet, and bringing it into being through skill and persistence. And Homo erectus did this for over 1 million years. The Acheulean industry first appeared around 1.76 million years ago, and persisted until around 200,000 years ago in some regions. The same basic design, refined and adapted but fundamentally unchanged, used by generation after generation after generation of erectus populations across Africa, Europe, and Asia. That's technological conservatism at a scale we can barely comprehend. But don't mistake conservatism for stupidity. Recent research suggests Homo erectus could switch between different tool technologies depending on circumstances. Older one tools, the simpler choppers of earlier hominins, sometimes appear alongside Acheulean hand axes at erectus sites. This suggests flexibility, the ability to choose the right tool for the job rather than slavishly following tradition. It's the mark of intelligence, knowing when the old way is better than the new. Then there's fire. This is where Homo erectus really changed the game. The earliest evidence for hominin use of fire dates back to around 1.8 million years ago, right at the beginning of the erectus story. By around 500,000 years ago, there's clear evidence of controlled fire, deliberately maintained hearths, cooking sites where meat and plant foods were systematically processed using heat. Fire is transformative in ways that are hard to overstate. It provides warmth, extending the range of habitats humans can occupy. It provides protection from predators, the one defense that works against everything from lions to hyenas to the unknown terrors of the night. It provides light, extending the useful day beyond sunset, creating time for social interaction, storytelling, teaching, all the activities that build and transmit culture. And most importantly, fire provides cooked food. Cooking breaks down tough plant fibers and proteins, making nutrients more bioavailable. It kills parasites and bacteria, reducing disease. It expands the range of foods that are edible, turning bitter tubers and toxic plants into viable food sources after proper preparation. Cooked food delivers more calories per unit of effort to gather and digest. And those extra calories fuel bigger brains, which require immense amounts of energy to maintain. There's a feedback loop here. Bigger brains allow better fire control. Better fire control allows more cooked food. More cooked food supports bigger brains. And round, driving encephalization, driving social complexity, driving the emergence of behaviors that look more and more human with each passing millennia. But the most impressive thing about Homo erectus isn't their tools or their fire or their brains. It's where they went. Because Homo erectus was the first hominin to leave Africa. not just to wander into the Sinai or the edges of the Middle East, but to truly disperse, to colonize new continents, to spread across the old world in a way that no hominin had done before. By around 1.8 to 1.9 million years ago, Homo erectus had reached the Caucasus region, modern-day Georgia. The fossils from Dmanisi are extraordinary, showing a population of early Erectus living in a temperate environment far from the African savannas where they evolved. These weren't the largest or most robust Erectus specimens. They had relatively small brains and primitive features, but they made it work. They survived in a colder climate, with different food sources, different predators, different challenges than their African relatives faced. From there, Erectus spread east into Asia. They reached China by at least 1.6 million years ago, possibly earlier. They made it to Java, Indonesia, where they would ultimately have their longest run, surviving until at least 117,000 years ago. That's over 1.5 million years of continuous Erectus presence in Southeast Asia. 1.5 million years of adaptation, of cultural transmission, of survival in tropical forests and volcanic landscapes. They even made it to Europe, though the evidence there is more fragmentary and the classification more debated. Some European fossils traditionally called Homo heidelbergensis might actually be late European Erectus or closely related species. The lines blur at the edges, which is how evolution actually works. But the point stands. Homo erectus went everywhere early humans could go without boats. This dispersal is astonishing when you consider the distances involved and the difficulties of the journey. Walking from East Africa to China is thousands of miles. Walking from Africa to Indonesia means crossing multiple mountain ranges, navigating forests and plains and coastlines, finding food and water in unfamiliar territories, avoiding new predators, adapting to new climates, and doing all of this without maps, without compass, without any technology beyond stone tools and fire. They did it through population pressure, probably. As groups grew too large for local resources to support, some individuals pushed into new territories. Sometimes they died. Sometimes they found new resources and established new populations. Over generations, over thousands, and then hundreds of thousands of years, this pressure pushed Erectus populations further and further from their African homeland. And here's the remarkable thing. They stayed connected. Not politically, obviously. Not even necessarily aware of each other as one grand Erectus civilization, but genetically connected enough that they remained recognizably the same species across vast geographic distances. A Erectus in China looked different from an Erectus in Africa, different enough that some researchers argue they should be classified as separate species. But most evidence suggests enough gene flow, enough occasional interbreeding between adjacent populations, that they maintained their identity as Homo erectus across their entire range. That's the species we're talking about when we say Homo erectus survived 2 million years. Not a static, unchanging population, but a dynamic, adaptable, geographically dispersed species that colonized 3 continents and survived everything Earth threw at them. They were the original cosmopolitan humans, the first true wanderers, the species that proved humans could live anywhere, could adapt to anything, could endure, and we're their descendants, at least in part. The African populations of Homo erectus, or something closely related, gave rise to Homo heidelbergensis, which gave rise to us. We carry their legacy in our bones, in our modern body plan that Erectus pioneered. We carry it in our brains, built on the foundation Erectus established. We carry it in our very nature as a species that wanders, that explores, that pushes into new territories seeking new opportunities. Homo erectus showed us what was possible. Now we need to see if we can match their endurance. But there's more to their story that makes them remarkable. The way they raised their young, for instance. The Turkana boy skeleton, despite being only about 8 years old when he died, shows evidence of a prolonged childhood compared to earlier hominins. His teeth suggest a growth rate somewhere between modern apes and modern humans. He was maturing faster than we do, but slower than chimpanzees do. This hints at an extended period of dependency, of learning, of cultural transmission from adults to children. Extended childhood is expensive in evolutionary terms. It means adults have to support offspring for longer periods. It means fewer babies overall, because each one requires more investment. But it also means each child can learn more, can acquire more complex skills, can be taught the accumulated wisdom of generations. Homo erectus was pioneering this strategy of quality over quantity in offspring, setting the stage for the even more extreme extended childhood that characterizes modern humans. And they cared for each other in ways that go beyond simple survival. The Dmanisi fossils in Georgia include that toothless old male we mentioned, but they also include individuals who survived severe injuries and disabilities. One individual had a badly infected jaw. Another shows signs of long-term malnutrition. These weren't robust, healthy specimens. These were vulnerable individuals who survived because someone took care of them. This is compassion. This is the beginning of what we might call morality, taking care of group members not because they contribute to your immediate survival, but because they're part of your community. It's the foundation of human empathy, visible in fossils that are over 1 million years old. They were beginning to develop the social bonds that would eventually make humans the most cooperative large mammal on the planet. Their sites also show evidence of shared meals, concentrations of animal bones with cut marks, stone tools clustered together, arrangements that suggest groups gathering to process and consume food communally. This is significant because sharing food isn't automatic. Many predators, even social ones, compete over kills. But humans share. We divide resources. We ensure everyone in the group gets fed. And Homo erectus appears to have been doing this over 1 million years ago. This social complexity, this cooperation, this care for the vulnerable, it wasn't just nice to have. Because Homo erectus wasn't the strongest predator on the landscape, they weren't the fastest, they didn't have the biggest teeth or the sharpest claws. What they had was each other. They survived through cooperation, through teaching, through taking care of their own, through being human in the ways that matter most. 2 million years. Most mammal species are lucky to last a few million years before they either go extinct or evolve into something different. Homo erectus hit that benchmark and just kept going. So what was their secret? What allowed them to endure when so many other species, including other hominins, disappeared? The answer isn't simple. It never is in evolution. But if we had to identify the core traits that made Homo erectus the ultimate survivors, we'd start with one word: flexibility. Not physical flexibility, though they were capable walkers. Behavioral and ecological flexibility, the ability to adapt their strategies to changing circumstances without losing their fundamental identity. Consider their diet. We know from studying tooth wear, stable isotopes in their bones, and the butchery marks they left on animal remains, that Homo erectus ate a remarkably varied diet. They hunted large game. Evidence suggests they took down animals as big as elephants and rhinoceroses, though whether through hunting or scavenging is still debated. They caught smaller animals, birds, rabbits, whatever they could get. They gathered plant foods, tubers, seeds, fruits, nuts. They exploited aquatic resources in some regions, fishing and collecting shellfish. This dietary breadth is crucial for long-term survival. Specialist species, the ones that depend heavily on one food source, are vulnerable to extinction when that resource disappears. Giant pandas, which eat almost exclusively bamboo, are constantly on the edge because their entire survival depends on bamboo forests remaining intact. Koalas, which eat only eucalyptus leaves, face similar vulnerability. Homo erectus avoided that trap. They were generalists, able to shift their diet based on what was available in their environment. Living in the tropics, focus on fruits and termites and monkeys. Living in temperate zones, shift to larger game animals and starchy tubers. Living near coastlines, add shellfish and fish to the menu. This flexibility meant that when climate change altered local ecosystems, as it did repeatedly over 2 million years, erectus populations could adjust their subsistence strategies rather than starving. But dietary flexibility alone doesn't explain 2 million years of survival. You also need the right tools, literally and figuratively. And here, Homo erectus excelled. Their stone tools, especially the Acheulean hand axes, were remarkable pieces of technology. A well-made hand axe could serve multiple purposes: cutting meat, processing hides, digging for tubers, working wood, even as a projectile in some contexts. What's fascinating is that these tools show evidence of both tradition and innovation. The basic form remained consistent across huge spans of time and space, suggesting strong cultural transmission. Young Erectus learned to make hand axes by watching their elders, preserving techniques that worked, but there's also variation, local styles and preferences that show populations weren't just mindlessly copying. They were adapting the basic template to local needs and materials. Recent discoveries have complicated this picture in interesting ways. At some Erectus sites, researchers find simpler Oldowan-style tools alongside the more advanced Acheulean implements. This isn't regression, it's pragmatism. Sometimes a simple flake is better for the job than an elaborate hand axe. Sometimes the available stone doesn't lend itself to bifacial shaping. Homo erectus apparently understood this. They used the right tool for the task rather than always defaulting to their most sophisticated technology. This kind of technological flexibility extends to their use of fire. Early evidence of fire use by hominins goes back to around 1.8 million years ago, possibly associated with early Erectus. But controlled use of fire, the ability to start fires rather than just maintain naturally occurring ones, seems to have developed later, perhaps around 500,000 years ago. What changed? Probably the environments Erectus populations were moving into. In tropical Africa, fire is useful but not essential. You can survive cold nights. Predators are a threat, but manageable. Food can be eaten raw if necessary. But as Erectus populations moved into cooler temperate zones, into northern China and Europe, fire became critical. It provided warmth on cold nights. It protected vulnerable sleeping groups from predators. It allowed cooking, which was essential for processing tough plant foods in regions where tropical fruits weren't available. So Erectus populations developed better fire management. They learned to create fire on demand using techniques we can only guess at, striking stones to create sparks, using fire drills to generate heat through friction. They learned to maintain fires for extended periods, banking them overnight, transporting embers when they moved camps. Fire became not just a tool, but a central organizing principle of their lives. And this brings us to another key factor in Erectus' success: social cooperation. Maintaining fire requires someone to tend it. Hunting large game requires coordinated group efforts. Raising children with their increasingly large brains and extended childhoods requires help from the community. Homo erectus couldn't have survived as lone individuals. They needed each other. Evidence for this comes from fossil discoveries that show care for injured and elderly individuals. The Dmanisi fossils include an elderly male who had lost most of his teeth years before he died. His jaw had resorbed, showing he'd been toothless for an extended period. How did he survive? He couldn't have processed tough foods on his own. Someone in his group must have helped him, perhaps pre-chewing food or selecting soft items he could manage. Similarly, fossils show Erectus individuals who survived serious injuries that would have left them temporarily or permanently disabled. Broken bones that healed, infections that resolved, injuries that should have been fatal but weren't, because someone cared for the injured individual while they recovered. This is the beginning of what we'd recognize as human empathy, taking care of group members not because they're immediately useful but because they're part of the social fabric. These social bonds probably extended beyond immediate family groups. Modern hunter-gatherers live in bands of 20 to 50 individuals, but maintain connections with other bands through kinship, trade, and periodic gatherings. Homo erectus likely did something similar, creating networks that helped them weather local disasters. If one group faced food shortages, they could move to join relatives in regions with better resources. If a population crashed due to disease or predation, survivors could join neighboring groups, maintaining genetic diversity and cultural knowledge. This social flexibility complements their ecological flexibility. When the environment changed, Erectus didn't just adjust what they ate. They adjusted where they lived, who they lived with, how they organized themselves. They were behaviorally plastic in ways that rigid, specialized species simply couldn't match. Another factor that doesn't get enough attention: their geographic range. By spreading across 3 continents, Homo erectus essentially diversified their risk. When conditions in Africa deteriorated, Asian populations survived. When Asian populations faced challenges, African lineages endured. They were too widespread to be wiped out by any localized catastrophe. Think about this in terms of modern risk management. If you invest all your money in one stock, you're vulnerable to that company failing. Diversify across many stocks, many sectors, even many countries, and you're protected against any single failure. Homo erectus, through their migrations, essentially diversified their evolutionary portfolio. They bet on multiple environments, multiple climate zones, multiple ecosystems, and that bet paid off for 2 million years. But perhaps the most important factor in erectus' success is one we can't measure directly: their reproductive strategy. To survive as a species for 2 million years, you need to maintain your population, not necessarily grow it explosively, but keep enough individuals alive and reproducing that you don't hit those dangerous bottlenecks where a single bad event causes extinction. Homo erectus apparently found the sweet spot. They didn't reproduce so fast that they exhausted their resources and crashed, but they reproduced steadily enough that losses from predation, disease, accidents, and normal mortality didn't drive them toward extinction. They maintained viable populations across their range, populations large enough to weather storms, but not so large that they destabilize their environments. This is harder than it sounds. Many species oscillate between boom and bust, expanding rapidly when conditions are good, then crashing catastrophically when resources run out. Homo erectus avoided this trap for 2 million years. They were the Goldilocks species. Not too hot, not too cold, but just right in terms of their population dynamics. And finally, there's an element we can't ignore: luck. Sometimes species go extinct not because they're poorly adapted, but because they're in the wrong place at the wrong time. An asteroid strikes. A supervolcano erupts. The climate shifts in ways that are simply too rapid to adapt to. Homo erectus survived not just because they were adaptable, but because the catastrophes that occurred during their time range, as numerous and severe as they were, never quite managed to wipe them out completely. That's the full package of erectus success: dietary flexibility, technological adaptability, social cooperation, geographic dispersal, stable population dynamics, and a hefty dose of good fortune. Put it all together, and you get a species that could weather almost anything. A species built for the long haul. The question we need to ask ourselves now is whether we, Homo sapiens, have those same qualities, or whether our different path, our rapid technological change, our explosive population growth, our transformation of global ecosystems represents a different strategy entirely. One that might be spectacularly successful in the short term but vulnerable in the long run. There's one more element of erectus success worth exploring: their relationship with environmental change itself. The Pleistocene epoch, which encompassed most of erectus's existence, was characterized by repeated glacial-interglacial cycles. Ice ages that locked up massive amounts of water in continental glaciers, lowering sea levels by hundreds of feet. Then warm periods where the ice melted and seas rose again. This cycle repeated dozens of times during Erectus's tenure on Earth. Each transition would have been catastrophic for species unable to adapt. When glaciers advanced, forests retreated, grasslands expanded or contracted, animal populations shifted, water sources dried up or appeared in new locations. The entire ecological landscape would transform within a few thousand years. That's rapid on evolutionary timescales, but slow enough that behavioral adaptation could keep pace if you were flexible enough. Homo erectus was flexible enough. When their environment changed, they changed their behavior, moved to new territories, adjusted their diet, modified their tool use. They didn't need to wait for biological evolution to save them. They could respond within a single generation through behavioral plasticity. This is the advantage of intelligence: the ability to solve problems with your brain rather than waiting for your genes to catch up. But they weren't so flexible that they lost their identity. They didn't speciate into dozens of different forms. They remained recognizably Homo erectus across their entire range and duration. This is the balance that's so hard to achieve. Change enough to survive, but not so much that you fragment into multiple species or transform into something entirely different. Modern Homo sapiens hasn't proven we can maintain this balance. We've been changing very rapidly, especially in the last few thousand years. Our behavior, our technologies, our social structures, all of it evolving at speeds that would have been incomprehensible to Erectus. We're adaptable, perhaps more adaptable than any previous human species. But we don't yet know if we can maintain this rapid pace of change without fragmenting, without creating divisions within our species that might eventually split us apart, without changing so fast that we lose track of what makes us human in the first place. Homo erectus gave us a template for endurance. Moderate everything. Adapt but don't revolutionize. Change when necessary, but maintain stability when possible. Spread out, but stay connected. These might seem like conservative strategies, and they are. But conservatism, in the right context, is another word for sustainability. And sustainability over 2 million years is success by any measure. 300,000 years ago, give or take, something new appeared in Africa. Not completely new, obviously. Evolution doesn't work in sudden jumps from one species to another, but new enough that if you could see the fossils side by side, you'd notice the difference. The skulls were rounder, higher, with less pronounced brow ridges. The faces were flatter, pulled back under the skull rather than jutting forward. The brains were larger, filling that rounded skull case with neural tissue that would eventually give rise to language, art, mathematics, and all the other capabilities we associate with being human. This was Homo sapiens, us, the new kids on the evolutionary block. The earliest fossils we have that look recognizably like modern humans come from Jebel Irhoud in Morocco, dated to about 315,000 years ago. These weren't quite modern humans as we define them today. The skulls were still longer and lower than ours. The faces, while flatter than Homo erectus, were still more prominent than modern humans. But the overall package was clearly something different from what came before, something transitional, something on its way to becoming us. Other early Homo sapiens fossils come from East Africa and South Africa. The Homo kibish fossils from Ethiopia, dated to around 196,000 to 233,000 years ago. The Florisbad skull from South Africa, around 260,000 years old, each showing a mix of archaic and modern features, like evolution, was trying out different combinations before settling on the final design. And that's exactly what was happening. Recent genetic evidence suggests that Homo sapiens didn't emerge from a single population in one location. Instead, we arose from multiple populations across Africa that were already partially separated, already developing distinct characteristics, but still interbreeding enough to eventually merge into one species. It was a messy, gradual process, not a clean break from what came before. What made us different from Homo erectus? The obvious answer is brain size. Modern human brains average around 1,300 cubic centimeters, significantly larger than the 1,000 cubic centimeter average for Erectus. But brain size alone doesn't tell the whole story. What matters is brain organization, the specific areas that are enlarged, and how they're connected to each other. The modern human brain has a distinctly rounded shape, with expanded parietal and temporal lobes. These areas are involved in spatial reasoning, language processing, social cognition, and abstract thought. Our frontal lobes, involved in planning and impulse control, are proportionally larger than in earlier humans. Our cerebellum, important for motor coordination and possibly for some aspects of cognitive processing, is reorganized in ways that distinguish us from other hominins. This reorganization happened gradually. The earliest Homo sapiens had brains that were modern in size, but not yet fully modern in shape. The globular brain case that characterizes modern humans seems to have developed around 200,000 to 100,000 years ago, and with that structural change came new capabilities, though we can't pinpoint exactly when or how suddenly they emerged. But here's the thing that should humble us. For most of our 300,000-year history, we weren't particularly special. We weren't obviously superior to other human species we shared the planet with. For 200,000 years, maybe longer, Homo sapiens was just another hominin species, making stone tools that weren't dramatically better than what Neanderthals or late Homo erectus were producing, hunting and gathering in ways that weren't fundamentally different from other humans. The Middle Stone Age in Africa, which corresponds to the rise of Homo sapiens, shows gradual innovations. Better stone tools? Yes. Some evidence of long-distance trade in raw materials. Possible use of pigments like ochre for symbolic purposes. But nothing revolutionary. Nothing that screams, this species is going to take over the planet. In fact, there's a frustrating gap in our understanding of early Homo sapiens behavior. The archaeological record from 300,000 to around 100,000 years ago is relatively sparse and ambiguous. We have stone tools, but they're not that different from what came before. We have hunting sites, but we can't always tell if the behavior was more sophisticated than earlier humans. What we don't see for a very long time is the package of behaviors we associate with behavioral modernity: representational art, complex projectile weapons, elaborate burials suggesting belief in an afterlife, jewelry and personal adornment, musical instruments, all the things that make us unmistakably human in a cultural sense. So what were we doing for the first 250,000 years? Surviving, obviously, reproducing, learning, but not transforming the world the way we would eventually. We were smart, probably smarter than other human species in some ways, but we weren't leveraging that intelligence into revolutionary new ways of living. Not yet. And we were vulnerable. Genetic evidence shows that Homo sapiens nearly went extinct multiple times in our early history. The famous bottleneck around 900,000 to 800,000 years ago, before we were even fully Homo sapiens, reduced the global human population to around 1,300 individuals. We squeaked through that one by pure luck. But there were other close calls. Around 130,000 years ago, climate change in Africa created harsh conditions. Droughts, resource scarcity. Archaeological evidence suggests human populations in many regions crashed or disappeared entirely. The humans who survived were probably concentrated in refuge areas, pockets of relatively stable climate where resources remained available, small populations clinging to favorable locations while the world around them became hostile. This is a very different story from Homo erectus. They spread out, diversified, colonized new territories. Early Homo sapiens stayed in Africa for most of our first 200,000 years. We weren't expanding. We were barely holding on. Whatever cognitive advantages our larger, reorganized brains gave us, they weren't enough to make us obviously successful compared to Erectus in their heyday. And we weren't alone. Around 300,000 years ago, the world was full of humans. Neanderthals were establishing themselves in Europe and Western Asia, perfectly adapted to cold climates with their robust bodies and large brains. The Denisovans, known mostly from genetic evidence, were somewhere in Asia. Homo naledi was in South Africa, though their exact dates are still debated. Possibly other species we haven't discovered yet, or haven't properly classified. Homo sapiens was just one more hominin in a crowded world. Not obviously dominant, not inevitably destined for success. Just another experiment in being human, trying to carve out an existence in a competitive landscape where multiple, intelligent, tool-using species were vying for the same resources. What changed? That's one of the great questions in human evolution. Somewhere between 100,000 and 50,000 years ago, something shifted. Homo sapiens developed or refined capabilities that previous humans hadn't possessed. Our technological sophistication increased dramatically. Our social organization became more complex. Our symbolic thinking, our ability to represent ideas through art and language and ritual, blossomed in ways that left archaeological traces we can still see today. Some researchers call this the Great Leap Forward, though that's probably an oversimplification. It wasn't a single leap. It was a series of innovations, building on each other, accelerating over time. Better tools leading to better hunting, success leading to larger populations, leading to more social complexity, leading to faster innovation. A feedback loop that eventually snowballed into the spectacular success of modern Homo sapiens. But that success was still in the future 300,000 years ago. When we first appeared, we were unremarkable. Slightly different from our ancestors, yes. Potentially capable of great things, perhaps, but not yet achieving them. not yet showing the world what Homo sapiens could become. We were the new arrivals, the young species, untested by the kinds of challenges that had shaped Homo erectus over their 2 million-year run. We had larger brains and rounder skulls and subtle differences in our cognition that would eventually matter enormously. But in those early days, we were just trying to survive, just trying to make it through the next drought, the next climate shift, the next period of resource scarcity, and we almost didn't make it. Multiple times, our population numbers dropped to dangerously low levels. We survived, obviously, because we're here, but it was closer than we like to admit. Closer than seems consistent with the idea that we were inevitable, that Homo sapiens was destined from the start to inherit the Earth. The truth is more humbling and more interesting. We weren't special at first. We were just another hominin, muddling through, trying to figure out how to survive in a difficult world. The fact that we eventually became special, that we eventually developed the capabilities that would make us the last humans standing, that's a story that took hundreds of thousands of years to unfold. And even then, even after we developed our full suite of modern behaviors, we still had to prove we could do what Homo erectus had done. We had to prove we could last. We had to demonstrate that our particular combination of traits, cognitive and social and technological, was compatible with long-term survival as a species. 300,000 years later, we're still working on that proof. Still trying to show that we can match Erectus's endurance. Still uncertain whether our explosive growth and rapid innovation represent genuine success, or a beautiful but brief flowering before an equally rapid decline. There's a number that should terrify anyone who understands what it means. 1,300. That's how many humans, or proto-humans, existed on Earth around 900,000 to 800,000 years ago. 1,300 individuals, total, globally, for over 100,000 years. Let that sink in. The entire human lineage, everything that would eventually become Homo sapiens and Neanderthals and Denisovans, was reduced to a population smaller than a large high school. One bad winter, one volcanic eruption, one disease outbreak. Any of these could have wiped us out completely, and this universe would have continued without us, indifferent to our absence. This wasn't a brief crisis. This was a sustained bottleneck, lasting 117,000 years, from around 930,000 to 813,000 years ago. Over 100 millennia of hanging by a thread, of populations so small that genetic diversity plummeted, that inbreeding was inevitable, that every generation faced the real possibility of being the last. Researchers discovered this bottleneck through genetic analysis. When you look at the DNA of modern humans, you find surprisingly little variation compared to other great ape species. Chimpanzees, despite having far fewer living individuals than humans, show much more genetic diversity. Gorillas, orangutans, bonobos, all of them have more genetic variety within their species than we do. This is the signature of a severe population crash. When a species goes through a bottleneck, rare genetic variants are lost. Only the genes carried by the survivors make it through to future generations. The smaller the population, the more severe the genetic loss. And our ancestors went through one of the most extreme bottlenecks ever documented in a large mammal. What caused it? Climate change, most likely. Around 900,000 years ago, Earth's climate shifted dramatically. Africa, where our ancestors were living, experienced severe glacial periods, with reduced rainfall and cooler temperatures. Forests shrank. The resources that had sustained larger populations simply weren't there anymore. Our ancestors responded the only way they could. Populations contracted into refugia, small areas where conditions remained tolerable. Most died. The ones who survived were lucky enough to be in the right place, to have access to resources that persisted when everything else collapsed. For over 100,000 years, they endured in these pockets of survival, populations so small that everyone knew everyone, that every death was a tragedy for the entire species. And here's the terrifying part. This happened before Homo sapiens even existed. This bottleneck shaped our ancestors, the populations that would eventually split into different human lineages. But it nearly ended us before we began. If those 1,300 individuals had failed to survive, If the climate had gotten just slightly worse, if luck had turned against them, there would be no Homo sapiens, no Neanderthals, no Denisovans, no humans at all. But wait, it gets worse. Because the bottleneck 800,000 years ago wasn't the only time Homo sapiens came close to extinction. It happened again and again throughout our 300,000-year history. Around 130,000 years ago, another severe climate event hit Africa. This one didn't reduce us quite as dramatically as the earlier bottleneck, but it came close. Archaeological evidence shows that human populations across much of Africa either disappeared or became extremely sparse. Sites that had been continuously occupied for thousands of years were suddenly abandoned. The tools and artifacts that mark human presence vanish from the record. Where did everyone go? Some died, certainly, but others contracted into the same kind of refugia that had saved our more distant ancestors. The southern tip of Africa appears to have been one such refuge. The evidence suggests small populations of Homo sapiens survived there, clustered along coastlines where they could exploit marine resources when the inland areas became too harsh to support human life. These weren't large, thriving populations. These were survivors, groups of maybe a few hundred individuals total, clinging to the margins of habitability. They had the coast on one side, providing shellfish and fish and seaweed. They had access to fresh water from springs and small streams. And they waited. For thousands of years, they waited while the world beyond their refuge remained hostile, while other human populations elsewhere died out or struggled in their own refugia. This pattern repeats throughout our early history. Homo sapiens expanding during favorable climate periods, then contracting during harsh ones, growing, then crashing, spreading out, then being pushed back into safe havens. We were never secure, never established firmly enough that we could weather any storm. We were always one catastrophe away from extinction. Compare this to Homo erectus. They went through the same climate fluctuations, the same droughts and cold periods, and environmental challenges. But they had advantages we didn't. They were already spread across multiple continents by the time we appeared. When Africa dried out, their Asian populations kept going. When Asia faced challenges, African erectus endured. They diversified their range so thoroughly that no single regional disaster could wipe them out. Homo sapiens didn't have that advantage for most of our history. We stayed in Africa, confined to one continent, vulnerable to African climate catastrophes. We didn't start leaving Africa in significant numbers until around 100,000 years ago, and even those early migrations mostly failed. The pioneers who left Africa between 100,000 and 70,000 years ago apparently died out without leaving descendants among modern populations outside Africa. It wasn't until around 60,000 to 70,000 years ago that Homo sapiens successfully established populations outside Africa. That's when we finally began the dispersal that would eventually spread us across the globe. But even then, we remained vulnerable in ways Erectus wasn't. Our populations were smaller. Our breeding rates seemed to have been lower. We invested more in each child, raising them for longer periods, which means we couldn't recover from population crashes as quickly. These are trade-offs that come with having large, expensive brains and complex social learning. There's another factor that nearly doomed us: our own behavior. As Homo sapiens populations grew and developed more sophisticated technologies, we began putting pressure on the ecosystems we depended on. There's evidence that early humans in some regions hunted large game animals to extinction or severe decline. When you depend heavily on megafauna for your protein, and then you hunt those megafauna into scarcity, you create your own crisis. This is something Homo erectus generally avoided. They were hunters, yes, but their populations remained small enough and their technologies simple enough that they didn't devastate their food sources. They existed in something closer to equilibrium with their environment. We, on the other hand, have been pushing against ecological limits since our earliest days as a species. The Toba supervolcano eruption around 74,000 years ago might have been another near-extinction event, though this is debated. Genetic evidence suggests human populations crashed around this time, possibly to as few as a few thousand individuals globally. The eruption was massive, one of the largest in the last 2 million years. It ejected massive amounts of ash and sulfur dioxide into the atmosphere, causing a volcanic winter that lasted years, possibly decades. Did it nearly wipe us out? Some researchers think so. Others argue that the genetic bottleneck around this time might have different causes, or might not have been as severe as some models suggest. The debate continues. But the fact that it's even plausible that a single volcanic eruption could have ended our species tells you how precarious our position was. And these aren't ancient problems that we've outgrown. Yes, our population is now enormous, over 8 billion people. Yes, we're spread across every continent. But we've also created new vulnerabilities. We depend on complex global systems for food, energy, and resources. We've altered the climate in ways that are creating new environmental challenges. We've reduced biodiversity to levels not seen since previous mass extinction events. In some ways, we're more vulnerable now than we were 10,000 years ago. Despite our larger numbers, our ancestors in small hunter-gatherer bands could survive independently. If one group failed, others continued. But modern humans are interconnected in ways that create systemic risk. A pandemic spreads globally in weeks. Economic collapse in one region cascades to others. Climate change affects the entire planet simultaneously. Homo erectus never created these kinds of risks. Their populations were small and dispersed enough that disaster in one region didn't affect others. Their technology was simple enough that they couldn't cause environmental damage on a global scale. They couldn't engineer their own extinction the way we potentially could. This is the fragility of being human, or at least of being Homo sapiens. We're innovative enough to transform our environment, but not foresighted enough to understand the long-term consequences until they're upon us. We survived the bottlenecks of our past through luck as much as skill, through being in the right refugia at the right times, through maintaining just enough genetic diversity to avoid the extinction vortex that claims small populations, through random chance that favored our survival over our extinction. Can we survive the challenges we're creating for ourselves now? That's the question that should keep us awake at night. Because unlike the climate catastrophes and volcanic eruptions of our past, the threats we face now are largely of our own making. And unlike our ancestors, who could wait out disasters in refugia and then expand again, we've filled the planet so thoroughly that there's nowhere left to retreat to. Homo erectus proved that humans could survive for 2 million years. But they did it through strategies we've largely abandoned. Small populations, simple technologies, living within ecological limits, spreading risk across vast geographic ranges without creating global interdependencies. A path of rapid growth, technological complexity, environmental transformation, and global integration. It's made us spectacularly successful in the short term, but in the long term? That's still an open question. One we won't know the answer to for thousands, maybe millions of years, assuming we last that long. And there's another dimension to our fragility that needs examination. Our genetic uniformity. The bottlenecks we've survived left permanent marks on our genome. When populations crash to tiny numbers, rare genetic variants disappear. Only the genes carried by the survivors continue into future generations. This reduces genetic diversity across the entire species, making us more vulnerable to future challenges. Modern humans have surprisingly little genetic variation compared to other great ape species. A population of just a few hundred chimpanzees in a single forest can have more genetic diversity than all 8 billion humans alive today. This tells you how severe our bottlenecks were. We passed through such narrow genetic filters that we're essentially all distant cousins, far more closely related to each other than random chimps or gorillas are to their neighbors. This lack of diversity has consequences. Genetic diversity is insurance against the unknown. Different genetic variants mean different susceptibilities to diseases, different abilities to tolerate environmental stresses, different metabolic strategies for coping with resource scarcity. When everyone's genome is similar, a disease that exploits common vulnerabilities can spread rapidly through the population. An environmental change that pushes against shared genetic limits can affect everyone simultaneously. Homo erectus, spread across 3 continents for 2 million years, probably maintained significant genetic diversity within their species. Different populations would have accumulated different mutations, adapted to different local conditions, developed distinct genetic characteristics. This diversity would have provided resilience. If disease or disaster struck one population, others with different genetic makeups might survive. We had that diversity once, when Neanderthals and Denisovans and late Homo erectus all existed as distinct populations with their own genetic variants. But we eliminated them, either through competition or absorption, and concentrated human genetic diversity into a single lineage. We put all our eggs in one basket, and now that basket is more uniform, more vulnerable than it's ever been. Some researchers argue that we're actually losing genetic diversity faster now than at any time since the agricultural revolution. As populations become more mobile, as people from different continents mix and have children, rare regional genetic variants are being diluted into the global gene pool. This seems counterintuitive. Shouldn't mixing increase diversity? But it doesn't work that way. Local adaptations, genetic variants that arose in specific populations in response to specific challenges, are disappearing as everyone becomes more genetically similar. This is another hidden cost of globalization. We're homogenizing ourselves genetically, just as we're homogenizing ourselves culturally, reducing the variation that evolution needs to work with if conditions change dramatically. We're making short-term trades, increase mobility and opportunity for individuals, in exchange for long-term vulnerabilities at the species level, and we won't know if this trade was wise until it's far too late to reverse it. Imagine waking up tomorrow and discovering that there are other kinds of humans, not different ethnicities or cultures, but actually different species. People who look almost like us but not quite, who think differently, who have their own languages and tools and ways of understanding the world, who have been around longer than we have, who have their own ancient civilizations and histories. That would fundamentally change how we think about ourselves, wouldn't it? We wouldn't be the pinnacle of creation. We'd just be one version of human among several. We'd have to negotiate, compete, potentially cooperate with these other humans, never quite sure if they were like us enough to be trusted or different enough to be threats. That was the world our ancestors lived in for most of our 300,000-year history. It was full of other humans. And for 260,000 years, we shared the planet with them. Sometimes peacefully, sometimes violently, always uneasily. The longest overlap was with Homo erectus. When Homo sapiens first evolved around 300,000 years ago, Erectus had already been around for over 1.7 million years. They were the old guard, the established species. They'd survived everything Earth could throw at them. They occupied territories across Africa, Asia, and possibly Europe. They were successful, numerous, and in no danger of disappearing anytime soon. Early Homo sapiens in Africa would have known about Erectus, though whether they ever met face to face is unknown. The earliest sapiens fossils are from North Africa and East Africa. Late Erectus populations persisted in East Africa until around 500,000 years ago, possibly later. There were millennia, maybe hundreds of thousands of years, when both species inhabited the same continent, hunted the same game, used similar tools. Did they interact? We don't know. The fossil record is silent on this, but it's hard to imagine they didn't, at least occasionally. Territory overlaps. Resources become scarce. Two different human species encounter each other at a waterhole, both groups wary, both armed with spears and stone tools. What happened in those moments? Did they fight? Trade? Share information? Mate? That last question is particularly interesting because we now know that different human species did interbreed. Not with Erectus, apparently. There's no genetic evidence for Sapiens erectus hybrids in modern human DNA. But the absence of evidence isn't evidence of absence. Maybe interbreeding happened, but the hybrid lineages didn't survive. Maybe it was rare enough that the genetic signal was lost. Or maybe the species were different enough that interbreeding wasn't possible, or didn't produce fertile offspring. But Homo sapiens definitely interbred with other human species. We know this because we found the DNA to prove it. Neanderthals were our closest relatives among other human species. They evolved in Europe and Western Asia around 400,000 to 250,000 years ago, probably from the same ancestral population that gave rise to us. They were superbly adapted to cold climates. Robust, muscular, with large brains that actually exceeded ours in size. They were sophisticated hunters, using complex tools, controlling fire, possibly having language, creating what might have been early art or symbolic objects. When Homo sapiens finally left Africa and spread into Europe around 45,000 years ago, Neanderthals had been there for hundreds of thousands of years. It was their home territory. They knew the landscape, the animals, the plants, the caves that provided shelter. They were established. And suddenly, these new humans showed up, competing for the same resources. For at least 5,000 years, probably longer in some regions, Homo sapiens and Neanderthals lived in the same areas. They hunted the same prey. They occupied caves that the other species had previously inhabited. And they had children together. We know this because non-African modern humans carry about 1 to 2% Neanderthal DNA. That percentage might seem small, but it represents multiple interbreeding events over thousands of years. Some of those Neanderthal genes are still functional in modern humans, affecting our immune systems, our metabolism, our susceptibility to certain diseases. We carry pieces of Neanderthals inside us, genetic memories of our encounters with them tens of thousands of years ago. What were those encounters like? We can only imagine. A Homo sapiens hunting party meets a Neanderthal family. There's tension, uncertainty. Weapons are readied but not used. Someone makes a gesture of peace. Maybe they trade. Maybe they share a meal. Maybe over time, relationships form. A sapiens woman joins a Neanderthal group or vice versa. Children are born who carry genetic material from both species. Those children apparently survived and had children of their own. Their descendants spread, carrying Neanderthal genes that natural selection sometimes favored. Genes for dealing with cold climates. Genes for fighting off European pathogens. Genes that helped Homo sapiens adapt to environments where Neanderthals had thrived for hundreds of thousands of years. Then there were the Denisovans, a group we knew nothing about until 2008. That's when researchers extracted DNA from a finger bone found in Denisova Cave in Siberia. The DNA was human but not quite Homo sapiens and not quite Neanderthal. It was something else. A third lineage that had split off from our common ancestor, adapted to Asia, and survived until at least 50,000 years ago, possibly later. We have almost no Denisovan fossils, just that finger bone, a few teeth, a piece of skull. But we have their DNA, and that DNA tells a remarkable story. Modern humans in Asia and Oceania carry Denisovan genetic material. Some populations, particularly in New Guinea and Australia, carry substantial amounts, up to 5% of their genome from Denisovans. This means extensive interbreeding occurred, not just once or twice, but repeatedly over thousands of years. Homo sapiens encountered Denisovans as they spread into Asia. The groups lived near each other, interacted, and had children together. Some of those Denisovan genes helped modern humans adapt to high altitudes. Tibetans, for instance, carry a Denisovan gene variant that helps them process oxygen more efficiently in the thin air of the Himalayan plateau. And there were probably others. Homo floresiensis, the hobbit species discovered in Indonesia, survived until at least 60,000 years ago, possibly 50,000. They stood about 3.5 feet tall with brains a third the size of ours. Yet they made sophisticated stone tools and hunted dwarf elephants on the island of Flores. Indonesia was on the route of human migration into Australia. Homo naledi in South Africa, if the controversial young dates are correct, might have overlapped with early Homo sapiens. Homo luzonensis in the Philippines, known from fossils dated to around 50,000 years ago, represents yet another species that we might have encountered as we spread across Asia. The world wasn't empty. It was crowded with different kinds of humans, and everywhere Homo sapiens went, we found others already there. The archaeological record hints at violence between groups, though it's hard to determine if conflicts were between species or within them. Sometimes we bred with them, creating hybrid children who carried genes from multiple human lineages, and sometimes we just lived alongside them, occupying adjacent territories, occasionally interacting but mostly keeping to ourselves. Different species of humans, sharing a planet, each pursuing their own survival strategies. But one by one, they disappeared. Homo erectus vanished from their last refuge on Java around 117,000 years ago, before most Homo sapiens populations even left Africa. Homo floresiensis disappeared around 60,000 to 50,000 years ago, right around the time modern humans were spreading through Southeast Asia. The Denisovans vanished, though we don't know exactly when, probably between 50,000 and 30,000 years ago. The Neanderthals held on the longest outside Africa. They survived in Europe until around 40,000 years ago, with the last populations perhaps persisting in isolated refugia until 35,000 or even 30,000 years ago. Then they too were gone, leaving behind only the genetic traces in our DNA and the archaeological evidence of their sophisticated culture. By 40,000 years ago, Homo sapiens was alone, the only human species left on the planet. Everyone else had vanished in what was, geologically speaking, an eye blink of time. 10,000 years earlier, maybe 20,000, there had been multiple human species. Why? That's one of the great debates in paleoanthropology. Did we kill them? Did we outcompete them for resources? Did we interbreed with them so extensively that they were absorbed into our population rather than going extinct? The answer is probably all of these things, in different combinations in different places. In some regions, Homo sapiens might have been more effective hunters, depleting the game animals that other humans depended on. In other areas, our larger population sizes might have allowed us to simply overwhelm smaller groups of other species through sheer numbers. The interbreeding complicates everything. When Neanderthals went extinct, their genes didn't entirely disappear. They live on in us. Some researchers argue this isn't extinction at all, but absorption. The Neanderthals didn't die out. They became part of us. Same with the Denisovans. But that's cold comfort if you're a Neanderthal watching your way of life disappear, your territories being taken over, your children choosing to join Homo sapiens groups, because that's where the future lies. Whether you call it extinction or absorption, the result is the same. Distinct human species that had existed for hundreds of thousands of years ceased to exist as separate lineages. And Homo sapiens inherited the Earth. Not because we were inevitably superior, but because we happened to be the ones who survived when everyone else didn't. We weren't necessarily better adapted than Neanderthals. They were stronger, possibly smarter in some ways, perfectly suited to their environments. We weren't obviously more advanced than the Denisovans, about whom we know almost nothing but who must have been successful to have persisted as long as they did. We survived. They didn't. And now we're alone, the last humans, looking back at a time when the world was richer, more diverse, full of different ways of being human. We won, if you can call it winning. But in winning, we lost something too. We lost the mirrors that other human species held up to us. We lost the perspective that comes from knowing there are other ways to be intelligent, to be social, to be human. Now, there's just us. Here's the uncomfortable truth. We're not special. Not in the ways we like to think we are. Homo sapiens didn't survive because we were stronger or tougher or better adapted to our environment than other human species. Neanderthals were stronger. Homo erectus was tougher, proven by their 2 million year survival record. Denisovans adapted to some of the most challenging environments on Earth. So, why are we the ones still here? What advantages did Homo sapiens possess that ultimately allowed us to outlast everyone else? The answer is messier and more accidental than most origin stories admit. We didn't win through superior design. We won through a combination of luck, timing, and a few key traits that happen to matter more than anyone expected. Let's start with our brains, since that's where everyone always starts when discussing human exceptionalism. Yes, we have large brains, around 1,300 cubic centimeters on average, but Neanderthals had larger brains, sometimes exceeding 1,400 cubic centimeters. Brain size alone doesn't explain our success. What matters is what's inside those skulls. The modern human brain has a distinct shape. It's more globular, more rounded than the brains of other human species. This isn't just cosmetic. That rounded shape reflects an expansion and reorganization of specific brain regions, particularly the parietal lobes and the cerebellum. These areas are involved in functions we consider distinctly human: spatial reasoning, social cognition, imagination, and the ability to think abstractly about things that don't physically exist. This reorganization appears to have happened relatively recently in our evolutionary history, probably within the last 200,000 years. Early Homo sapiens had large brains, but they weren't fully modern in shape. The globular brain case that characterizes us developed gradually, alongside the emergence of what archaeologists call behavioral modernity. What is behavioral modernity? It's the package of traits that make us unmistakably Homo sapiens in our behavior, not just our anatomy, complex language, symbolic thinking, elaborate social structures, long-distance trade networks, innovation and creativity, expressed through constantly changing technologies and cultural practices. And here's the thing. We weren't born with these capabilities fully formed. The earliest Homo sapiens didn't immediately start creating art and building complex societies. For 200,000 years, our stone tools were similar to what other human species made. Our social structures were probably comparable. Whatever potential our reorganized brains gave us, we didn't start fully exploiting it until late in our history as a species. But when we did start exploiting it, somewhere between 100,000 and 50,000 years ago, things changed rapidly. We began making composite tools, spears with multiple parts carefully hafted together. We created projectile weapons, atlatls, and eventually bows and arrows that allowed us to hunt from a distance with devastating accuracy. We developed fishing technologies, hooks and harpoons and nets that gave us access to aquatic resources other humans exploited less efficiently. These innovations gave us an edge, not because we were smarter in some abstract sense, but because we were better at cultural transmission. We could maintain and build upon innovations from previous generations. We developed what anthropologists call cumulative culture, the ability to add new knowledge to existing knowledge, creating an ever-growing toolkit of skills and technologies. Neanderthals had culture too. They made sophisticated tools. They cared for their injured and buried their dead. They possibly had symbolic thought, and maybe even language. But they don't seem to have accumulated cultural innovations as rapidly as Homo sapiens. Their tools changed slowly over hundreds of thousands of years. Ours changed dramatically over just a few thousand years. Why? One possibility is population size. Modern human populations appear to have been larger than Neanderthal populations, sometimes significantly so. Larger populations mean more potential innovators, more people experimenting with new techniques, more opportunities for successful innovations to spread. There's a mathematical principle here. In small populations, new innovations are easily lost. Someone discovers a better way to make a tool or process food, but then they die before they can teach enough people. The innovation disappears. In larger populations, innovations have more chances to spread before they're lost. And once enough people know a technique, it becomes established, part of the cultural repertoire that gets passed down. Homo sapiens also seem to have had more extensive social networks. We lived in larger groups and maintained connections with other groups across wider geographic areas. Archaeological evidence shows that Homo sapiens were trading materials over hundreds of miles from their sources. Shells from the coast, found at inland sites. High-quality stone from specific quarries distributed across entire regions. These long-distance exchange networks indicate social connections that spanned vast territories. Why does this matter? Because larger social networks mean faster information flow. A useful innovation discovered in one group can spread to others through these trading connections. Ideas move along the same paths as goods. This creates a kind of collective intelligence, where the innovations of many groups are pooled and shared, accelerating the pace of cultural evolution. Compare this to Neanderthals, whose archaeological evidence suggests smaller groups and more limited exchange networks, or to late Homo erectus, whose stone tool technologies remained essentially unchanged for hundreds of thousands of years. They weren't stupid, they were socially isolated in ways that limited their cultural evolution. Another advantage, subtle but crucial, was our diet. Homo sapiens exploited a wider range of food sources than most other human species. We hunted large game, yes, but we also took small animals, birds, fish, shellfish, and a huge variety of plant foods. This dietary breadth made us less vulnerable to the disappearance of any single resource. There's evidence that Neanderthals relied heavily on large game animals, particularly in Europe. This made them effective hunters, but also vulnerable. When climate change affected the populations of large herbivores, Neanderthal food security suffered. Homo sapiens, with our more diverse diet, could shift to alternative resources when our primary food sources declined. We also developed better food processing technologies. Grinding stones for processing plant foods, systematic use of fire for cooking, storage techniques for preserving foods across seasons. These technologies allowed us to extract more nutrition from the environment and to maintain stable food supplies even when resources were scarce. Then there's our reproductive strategy. Homo sapiens women appear to have been able to support higher birth rates than Neanderthal women, not dramatically higher, but enough to matter over thousands of years. If Homo sapiens populations could replace losses more quickly, maintain stable numbers through difficult periods, and expand more rapidly when conditions improved, that's a significant advantage in any long-term competition. Why higher birth rates? Possibly because of our diet. Better nutrition supports pregnancy and lactation. Possibly because of our social structures. If Homo sapiens groups cooperated more extensively in childcare, allowing grandmothers and other group members to help raise children, mothers could have babies at shorter intervals. This is pure speculation, but it fits with other evidence of our enhanced social cooperation. And then there's the advantage that's hardest to quantify. Our adaptability. Not just behavioral flexibility, though that matters, but something deeper. A willingness to experiment. A tolerance for novelty. A cultural tendency toward innovation rather than tradition. Homo erectus survived for 2 million years with essentially conservative strategies. They found approaches that worked and stuck with them. This was a successful strategy for a very long time, but it also made them potentially vulnerable when circumstances changed rapidly. Conservative strategies work great in stable environments. In rapidly changing environments, adaptability matters more. Homo sapiens, for better or worse, embraces change. We innovate constantly. We experiment with new technologies, new social arrangements, new ways of doing everything. Some of these experiments fail. Many fail. But enough succeed that we're constantly adapting to new circumstances, pushing into new niches, finding new ways to solve old problems. This makes us unpredictable and sometimes destructive. We're the species that can't leave well enough alone. That's always trying to improve things, even when they're working fine. But in a world of rapid climate change and environmental upheaval, unpredictability and constant innovation can be advantages. Climate was changing dramatically during the period when other human species went extinct. The stable conditions that had allowed Homo erectus to persist for so long were breaking down. In this context, the human species best able to rapidly adapt to new conditions, to innovate new solutions, to change strategies when old ones stopped working, that species had an edge. That species was us. Not because we were inherently better, but because our particular combination of traits, large populations, extensive social networks, diverse diets, high birth rates, and a cultural tendency toward innovation happened to be exactly what was needed in that moment of Earth's history. It's almost embarrassing how contingent it all is. If climate change had been less severe, Neanderthals might still be here. If Homo erectus populations in Asia had maintained larger numbers, they might have survived longer. If any number of small things had gone differently, the outcome might have changed. We didn't win through superiority, we won through circumstance. Our advantages weren't part of some grand design. They were accidents of evolution that happened to align with the challenges we faced. And that should humble us, because it means our current dominance is just as contingent. Homo erectus survived 2 million years with their approach. We've survived 300,000 with ours. The question isn't which approach is better, in some abstract sense. The question is which approach works for the circumstances we're facing right now, and whether our constant innovation, our rapid change, our transformation of the environment represents a sustainable strategy or just a different path toward the same end that claimed all the other human species. Around 70,000 years ago, something changed. After spending over 200,000 years confined mostly to Africa, Homo sapiens began moving out in numbers that would actually stick. Earlier attempts at leaving Africa had mostly failed, small groups venturing into the Middle East only to die out or retreat. But this time was different. This time, we kept going. What triggered this exodus? We don't know for certain. Climate change might have played a role, making parts of Africa less hospitable while opening corridors through the Sahara and the Middle East. Population pressure could have been a factor, growing numbers, forcing groups to push into new territories. Or maybe it was cultural, the development of new technologies or social organizations that made long-distance migration possible in ways it hadn't been before. Whatever the cause, Homo sapiens began spreading out of Africa in waves. Some groups moved north through Egypt and into the Levant. Others possibly crossed the Bab el-Mandeb Strait at the southern end of the Red Sea, moving into Arabia and from there along the coastlines of Asia. These weren't armies. These weren't organized invasions. They were small groups of families, maybe a few dozen individuals, pushing into territories adjacent to their homelands, then their children pushing further, generation after generation, expanding the range of our species. By 60,000 years ago, Homo sapiens had reached Australia. Think about what that means. Getting to Australia required sea crossings, not just wading across shallow straits, but actual ocean voyages out of sight of land. We had to develop boats or rafts capable of carrying people, water, and supplies across dozens of miles of open ocean. We had to have the cognitive capacity to plan such journeys, to understand that land existed beyond the horizon even though we couldn't see it. This wasn't accident or luck. This was deliberate exploration backed by sophisticated maritime technology and complex planning. And it happened relatively early in our expansion out of Africa, suggesting that Homo sapiens had developed capabilities that other human species simply didn't possess. By 50,000 years ago, we were in Southeast Asia and New Guinea. By 45,000 years ago, we'd reached Europe, moving into territories that Neanderthals had occupied for hundreds of thousands of years. By 30,000 years ago, we were in Siberia, living in some of the harshest environments humans had ever inhabited. And by 15,000 to 20,000 years ago, we'd crossed into the Americas, the last major landmasses to be colonized by humans. In less than 60,000 years, Homo sapiens spread from Africa to every continent except Antarctica. We occupied rainforests and deserts, mountains and coastlines, Arctic tundra, and tropical islands. We adapted to every climate, every ecosystem, every environmental challenge the planet could present. No other human species had achieved anything close to this geographic range. But here's the disturbing part. Everywhere we went, we left death in our wake. The megafauna extinctions are the most obvious evidence. Large mammals, the animals we now call Ice Age giants, began disappearing shortly after humans arrived in each new region. In Australia, giant marsupials weighing up to 3 tons vanished around 50,000 years ago. In Europe and Asia, mammoths, woolly rhinos, cave bears, and giant deer disappeared between 40,000 and 10,000 years ago. In North and South America, dozens of genera of large mammals went extinct between 15,000 and 10,000 years ago. The pattern is too consistent to be coincidence. These extinctions don't correlate perfectly with climate change. They correlate with human arrival. When Homo sapiens showed up, the megafauna died out. Not immediately, but within a few thousand years, which is essentially instantaneous in geological terms. Why? Probably because we were efficient hunters with sophisticated weapons and cooperative hunting strategies. We could take down animals that had never evolved defenses against tool-using, strategic predators, and we didn't need to hunt them to extinction deliberately. We just needed to kill them faster than they could reproduce. Large mammals have long generation times, slow breeding rates. They can't recover quickly from heavy predation. But the megafauna weren't the only casualties of our expansion. Other human species disappeared too, in the same geographic pattern as we spread out of Africa. Homo erectus vanished from Java around 117,000 years ago. This was before the main out of Africa expansion, but modern Homo sapiens populations had begun moving into Southeast Asia. We don't know, but the timing is suggestive. The Denisovans disappeared sometime between 50,000 and 30,000 years ago. We have too few fossils to pin down their extinction precisely, but genetic evidence shows they were still around when Homo sapiens was spreading through Asia. We interbred with them, which means we definitely encountered them. Then they were gone. Homo floresiensis, the hobbits of Indonesia, survived until at least 60,000 years ago, possibly 50,000. Again, right around the time Homo sapiens was moving through the region. Modern humans were in Australia by 60,000 years ago, which means we passed through Indonesia. It's hard to imagine we didn't meet the hobbits. Then they went extinct. And the Neanderthals, our closest relatives, held on until around 40,000 years ago, maybe 35,000 in their last refugia. They'd survived in Europe and Western Asia for hundreds of thousands of years. They'd weathered ice ages, climate swings, changing environments. They were tough, smart, well adapted. Then Homo sapiens arrived in Europe around 45,000 years ago. Within 5,000 to 10,000 years, the Neanderthals were gone. Did we kill them? That's the question that haunts paleoanthropology. And the honest answer is, we don't know. There's very little direct evidence of violence between Homo sapiens and Neanderthals, no mass graves full of Neanderthal bodies with stone tool injuries, no battlefield sites where the two species clearly fought. But there doesn't have to be warfare for one species to replace another. Competition is enough. If Homo sapiens groups were better at hunting, they'd deplete the game animals in an area. Neanderthal groups would struggle to find food. Their populations would decline. Neanderthals would be pushed into marginal lands where survival was harder. Over generations, over thousands of years, this pressure would mount. Neanderthal populations would shrink. They'd become scattered, isolated from each other, unable to maintain viable breeding populations. Eventually, they'd hit the extinction threshold where the population is too small to recover, and they'd fade away, not with a bang but with a whimper, the last few individuals dying without leaving any descendants. This is called competitive exclusion in ecology. When two similar species compete for the same resources, one eventually drives the other to extinction. Not through violence, necessarily, just through being slightly better at surviving in the shared environment. And Homo sapiens, with our advantages in innovation, social organization, and adaptability. But there's another possibility that complicates this narrative: the interbreeding. We know Homo sapiens bred with Neanderthals. We know we bred with Denisovans. What if these other human species didn't go extinct so much as get absorbed into our population? Imagine you're a Neanderthal around 40,000 years ago. Your population is declining. Food is scarce. The territories your people have held for generations are being taken over by these new humans from Africa. Your young people are leaving, joining Homo sapiens groups where there's more food, more mates, more opportunities. But generation by generation, your culture fades. Your language is forgotten. Your children intermarry with sapiens until the distinction between Neanderthal and Homo sapiens is lost. Is that extinction? Or is it assimilation? For all practical purposes, Neanderthals cease to exist as a separate species. But pieces of them live on in us. This might be what happened to all the other human species. Not clean extinctions, but messy absorptions, with varying degrees of interbreeding, creating hybrid populations that were primarily Homo sapiens, but carried genetic contributions from multiple human lineages. We didn't just replace everyone else. We absorbed them, taking their genes and possibly some of their cultural knowledge, while overwhelming their distinct identities. The end result is the same. By 40,000 years ago, maybe 30,000, Homo sapiens was alone, the last human species standing. Every other lineage was gone, extinct or absorbed, leaving only genetic traces in our DNA and scattered fossils in caves and sediments. We'd gone from one species among many to the only human left on Earth in less than 30,000 years. That's phenomenally rapid in evolutionary terms. A blink of an eye, and the speed of it suggests something more than just normal competitive processes. This was a replacement event, a fundamental restructuring of human diversity that happened faster than anything in the previous 2 million years of human evolution. Homo erectus had coexisted with multiple other hominin species for most of their existence. Australopithecines, Paranthropus, Homo habilis, various other early Homo species. They'd shared Africa and eventually Asia with numerous other hominins, and everyone had managed to find their niche, to carve out their own way of surviving without driving everyone else to extinction. But when Homo sapiens expanded, that coexistence ended. We didn't share the planet, we took it over. Whether through superior competition, absorption through interbreeding, or some combination of both, we eliminated every other human lineage. This is the Great Replacement, the moment when human diversity collapsed down to a single species, when the rich ecosystem of different human types was simplified to just us. It's the moment we became alone, without rivals, without competition from other intelligent species. And it happened so fast, so completely, that we barely had time to document it. One moment there were Neanderthals and Denisovans, and possibly others. The next moment, there was just us, looking around at an empty world, wondering where everyone went. We'd won. We'd inherited the Earth. But in winning, we'd lost something too. We'd lost the only beings who could truly understand us, who shared our level of intelligence and self-awareness. We'd become the loneliest species on the planet. And we've been alone ever since. There's a detail about this replacement that's worth dwelling on, because it reveals something fundamental about what happened. The sheer rapidity with which other human species disappeared once Homo sapiens arrived in their territories. In evolutionary terms, it happened in the blink of an eye. 10,000 years. 20,000 at most. That's nothing. That's 100 generations. That's so fast that the other species barely had time to adapt, to develop counter-strategies, to figure out what was happening to them before it was over. Compare this to how Homo erectus coexisted with other hominins. When Erectus first appeared, Australopithecines were still around. Paranthropus species lived alongside them. Homo habilis overlapped with early Erectus, and they coexisted for hundreds of thousands of years. Yes, eventually the other species went extinct. But it happened slowly, over timescales that allowed for adaptation, for species to adjust to each other's presence, for ecological niches to be carved out and maintained. The Homo sapiens replacement was different. It was faster, more complete, more total. And the speed suggests something about our impact, about how disruptive our presence was to established ecological patterns. We weren't just another predator. We were something new, something that existing species hadn't evolved defenses against. This rapid replacement pattern repeats itself throughout human history, even after other human species were gone. When Homo sapiens reached Australia, the megafauna disappeared within a few thousand years. When we reached the Americas, the same thing happened. When we reached Madagascar and New Zealand, the giant flightless birds and lemurs vanished shortly after our arrival. Every time humans enter a new environment, we cause an extinction pulse. We're remarkably consistent in this. And this raises an uncomfortable question. Are we, by our very nature, incompatible with diversity? Does human success inherently require the simplification of ecosystems, the elimination of competing species, the transformation of complex biological communities into simpler ones, dominated by humans and our domesticates? Homo erectus lived for 2 million years without causing this kind of systematic disruption. What's different about us? Part of it is probably our population densities. We reproduce faster, maintain larger populations, fill territories more completely than Erectus did. Part of it is our technology. We hunt more effectively, process resources more thoroughly, extract more from our environment than any previous human. Part of it is our psychology. We're innovators, experimenters, constantly trying new approaches. This makes us adaptable, but it also makes us unpredictable and potentially destabilizing to ecosystems that had reached equilibrium. Whatever the cause, the pattern is clear. When Homo sapiens arrives, diversity declines. Other species, including other humans, disappear, and we're left alone in an ecosystem we've simplified, surrounded by the ghosts of what came before. This is the Great Replacement, not just of other humans, but of complex, diverse biological communities everywhere we spread. There's something profoundly lonely about being the only human species left on Earth. For the entire span of recorded history, for all of civilization, for every moment any living person can remember or document, there's only been us, Homo sapiens, alone. But for most of human evolutionary history, that wasn't true. We lost mirrors that could reflect back different ways of being human. We lost genetic diversity that might have helped us adapt to challenges we can't yet imagine. We lost cultures and knowledge systems that took hundreds of thousands of years to develop. Start with the Neanderthals, since we know them best. They weren't brutish cavemen, despite how they're often portrayed. They were sophisticated humans with large brains, complex tools, and rich cultural lives. They controlled fire, built shelters, wore clothing. They cared for their sick and injured. They buried their dead, sometimes with what appear to be grave goods, suggesting belief in an afterlife or at least ritual respect for the deceased. They created art, or something like it. Pierced shells and animal teeth that might have been jewelry or symbolic objects. Cave paintings in Spain that might predate the arrival of Homo sapiens in Europe, though this is controversial. Evidence of pigment use, ochre and manganese, possibly for body decoration. These aren't the behaviors of simple-minded brutes. These are the behaviors of people with internal lives, with imagination, with culture, and they were different from us in ways that might have been valuable. The occipital lobe at the back of the brain, involved in visual processing, was proportionally bigger in Neanderthals. This might have given them superior visual spatial abilities, better at navigating complex terrain, tracking animals, remembering landscapes. Their sensory processing might have been different from ours in ways we can barely imagine. They were also incredibly strong. Neanderthal skeletons show massive muscle attachments, bones thickened by a lifetime of physical stress. They could exert force that modern humans simply can't match without intensive training. This wasn't just useful for hunting. Thanks for watching. Things at Kasten next time. It was a different way of interacting with the physical world, of shaping materials, of moving through difficult terrain. What knowledge did they possess that we lost? They'd survived in Ice Age Europe for hundreds of thousands of years. They knew that landscape intimately, knew which plants were edible, which animals were approachable, where to find shelter, how to survive winters that would kill us. They'd accumulated survival knowledge through countless generations, knowledge that disappeared when they did. Some of that knowledge might have been transmitted to us through the interbreeding that occurred. Not just genes, but cultural information, techniques, stories about the land and its resources. But most of it probably died with the last Neanderthals, lost to time because we were too different, too competitive, or too incurious to learn from them while we had the chance. The Denisovans are even more mysterious because we know so little about them. A handful of fossils, a genome sequence, genetic traces in modern Asian and Oceanian populations. But what were they really like? What made them distinct from Neanderthals and Homo sapiens? We know they adapted to high altitudes. Modern Tibetans carry a Denisovan gene variant that helps them process oxygen efficiently in thin mountain air. This suggests Denisovans lived in or regularly traveled through high-altitude environments. They developed biological adaptations that we didn't, adaptations that are now helping their genetic descendants survive in one of Earth's most challenging environments. What else did they adapt to? The Denisovan range seems to have extended across much of Asia. They might have developed resistance to tropical diseases, adaptations for dealing with extreme heat or monsoon conditions, knowledge of Asian plant and animal species that we had to learn from scratch when we arrived. And Homo erectus, the species that lasted nearly 2 million years, what did they know that we've forgotten? They survived climate swings that would have devastated less adaptable species. They spread across 3 continents with Stone Age technology. They persisted through conditions that drove other hominins to extinction. They must have possessed survival skills we can barely comprehend. Knowledge of how to find water in dry landscapes, how to track game animals across vast distances, how to process difficult plant foods into edible form, how to predict weather patterns and seasonal changes, how to maintain social cohesion in small groups, isolated from other humans for generations at a time. Some anthropologists argue that modern hunter-gatherers preserve some of this ancient knowledge. The San people of the Kalahari, the Aboriginal Australians, the various indigenous groups who maintain traditional lifestyles into the modern era, they might carry forward survival techniques that go back hundreds of thousands of years. But even these groups have lost continuity with deep time. Homo erectus disappeared over 100,000 years ago. Whatever they knew, it's gone, filtered through too many generations of cultural evolution to preserve its original form. And this raises uncomfortable questions about what we're losing right now. Because the disappearance of other human species isn't ancient history. It's a pattern that continues. Indigenous knowledge systems are disappearing at an accelerating rate as traditional cultures are overwhelmed by globalized modernity. Languages go extinct, taking with them unique ways of categorizing and understanding the world. Survival techniques, adapted to specific environments, are forgotten as people move to cities. We're still causing extinctions, still losing diversity, still simplifying the world down to a single human monoculture. And just like the disappearance of Neanderthals and Denisovans, we probably won't realize what we've lost until it's too late to recover it. But the loss goes beyond practical knowledge. When other human species disappeared, we lost alternative models of consciousness, different ways of being intelligent, of being social, of being human. Neanderthal brains were organized differently from ours. Did they think differently? Experience the world differently? Have mental capabilities we lack, even as we have capabilities they lacked? We'll never know. We can't ask them. We can only study their artifacts and try to infer their internal lives, which is like trying to understand someone's personality by examining their trash. You can learn something, but you miss the essential reality of what it was like to be them. The same applies to all the extinct humans. Each species represented a different experiment in cognition, a different solution to the problem of being intelligent. And now they're all gone, leaving us as the only model, the only example of how a smart, tool-using species can exist. We have no comparison point, no way to know if our kind of intelligence is optimal or just what happened to survive. From a scientific perspective, this is tragic. Imagine if there were multiple sentient species alive today, not just different races or cultures of Homo sapiens, but actually different species with different evolutionary histories. We could study the development of intelligence in real time, compare different cognitive architectures, understand what's universal about consciousness and what's specific to our particular evolutionary path. Instead, we're alone. The only self-aware species on the planet. The only ones who can look back and wonder what it all means. And paradoxically, this makes it harder to understand ourselves because we have no frame of reference. No alternative versions of humanity to measure ourselves against. There's also the question of genetic diversity. When Neanderthals and Denisovans disappeared, their unique genetic variants mostly disappeared with them. Yes, we carry small percentages of their DNA through interbreeding, but the vast majority of their genomes are gone, lost forever. Genetic variations that took hundreds of thousands of years to evolve, deleted from the human lineage in a few thousand years. Some of those lost genes might have been valuable. Immunity to diseases we haven't encountered yet. Metabolic adaptations that would help in changing climates. Cognitive variations that would solve problems we haven't faced. We'll never know what we lost because those genes are gone, existing only as fading traces in our DNA. Modern humans are genetically uniform compared to other great apes. We have less genetic diversity than chimpanzees, gorillas, or orangutans, despite having far larger populations. This uniformity reflects our recent bottlenecks and the loss of other human lineages. We're all descended from a relatively small founding population that expanded rapidly without time to accumulate much variation. This lack of diversity is a vulnerability. Genetic uniformity makes species susceptible to diseases, to environmental changes, to any challenge that exploits common weaknesses. If a pandemic emerged that targeted genes we all share, having Neanderthal variants in the population might have saved some individuals. But those variants are mostly gone now. We're more vulnerable because we're more uniform. And finally, there's the cultural loss. Each extinct human species had their own traditions, stories, songs, ways of understanding the world. We'll never hear Neanderthal music or Denisovan poetry. We'll never know what stories Homo erectus told around their fires during those 2 million years. We'll never learn how they explained the stars, the seasons, birth and death, all the mysteries that conscious beings naturally wonder about. This cultural diversity might have enriched us if we'd preserved it. Different approaches to social organization, childcare, conflict resolution, cooperation, alternative philosophies, different values, ways of living that we never considered because we eliminated everyone who practiced them. Instead, we're left with a single surviving branch of the human family tree. And while that branch has diversified enormously, creating thousands of cultures and languages and traditions, it's all variations on a single theme. All Homo sapiens, all sharing the same basic cognitive architecture, the same fundamental ways of processing the world. We won. We're the last humans. But in winning, in eliminating all the other branches of our family, we've impoverished ourselves in ways we're only beginning to recognize. We're alone on a planet that was once full of different kinds of minds, different ways of being human. And that loneliness, that singular status, is both our triumph and our tragedy. So, here we are, at the end of this journey, through deep time. And if you've been paying attention, you should be left with a question that doesn't have an easy answer. Who was more successful? Homo erectus, who survived for nearly 2 million years, or Homo sapiens, who've only been around for 300,000, but have transformed the planet in ways no other species has? The answer depends entirely on how you define success, and that's the paradox at the heart of this story. Because by some measures, we're the most successful species in Earth's history. By others, we're a dangerous experiment that's still unproven. Let's start with the ways we're winning. Population numbers, for instance. At our peak, Homo erectus probably never exceeded a few million individuals globally, and that's generous. Most estimates put their total population much lower, perhaps hundreds of thousands at any given time. We, on the other hand, are 8 billion strong and counting. We've filled every habitable continent. We exist in numbers that would have been incomprehensible to any previous human species. We've also achieved geographic dominance that Erectus never managed. They spread across Africa, Asia, and possibly Europe. Impressive for their time. But we've gone further. We've colonized the Arctic, surviving in conditions that would kill Erectus in days. We've settled the high Andes and Himalayas, living at altitudes where oxygen is scarce. We've populated remote Pacific islands, crossing thousands of miles of open ocean to reach them. Our technological capabilities are beyond anything Erectus could have imagined. They made hand axes that remained essentially unchanged for 1 million years. We went from stone tools to smartphones in a few thousand years. We've split the atom, sequenced our own genome, sent probes beyond the solar system. We've also accumulated culture at a rate no other species has matched. Art, music, literature, philosophy, mathematics, science. We've created systems of meaning that let us share information across generations, building on the discoveries of our ancestors in ways that accelerate our advancement exponentially. Each generation starts from a higher baseline than the one before, and we've bent the environment to our will. We've domesticated plants and animals, turning wild species into forms that serve our needs. We've built cities that house millions. We've altered the chemistry of the atmosphere, the temperature of the oceans, the composition of the biosphere. For better or worse, we've become a geological force, leaving marks on the planet that will be visible millions of years from now. By these measures, Homo sapiens is the most successful human species ever. We've achieved dominance over our environment in ways that Erectus never approached. We're the apex predator, the dominant intelligence, the species that remade the world in our image. But here's where the paradox emerges. Because success in evolution isn't measured in achievements, it's measured in survival. And by that measure, Homo erectus is still winning. They lasted 2 million years. We've lasted 300,000. We're not even close to matching their record. Longevity matters in evolution because it's the ultimate test. Any species can have a brief moment of dominance. Many have. The dinosaurs ruled for over 160 million years, then went extinct. Millions of species have risen, thrived, and disappeared. The question is whether your time lasts. And here's what should terrify us. All the things that make us seem successful, our huge population, our technological sophistication, our environmental dominance, these might actually be vulnerabilities rather than strengths when viewed on evolutionary timescales. Take population size. 8 billion humans is impressive, but it's also precarious. We're dependent on complex systems for food, water, energy, global supply chains that can fail if disrupted, agricultural systems that require stable climates and abundant fossil fuels, cities that would become death traps if the infrastructure collapsed. Our huge population is only sustainable because of technologies and systems that are historically unprecedented and potentially fragile. Homo erectus never faced this vulnerability. Their small populations lived directly off the land. They weren't dependent on agriculture, trade networks, or complex infrastructure. If one group failed, others continued independently. They had built-in resilience through their small numbers and dispersed populations. We've traded that resilience for carrying capacity, betting that our systems will continue functioning indefinitely. Or consider our technology. It's advancing so rapidly that we're creating capabilities before we fully understand their consequences. Nuclear weapons that could end civilization in hours. Genetic engineering that could accidentally create new pandemics. Artificial intelligence that might surpass human control. Climate modification that's already causing unpredictable changes to global systems. Each technological advance creates new risks alongside new capabilities. Homo erectus never faced these risks because their technology was limited. Hand axes can't destroy civilizations. Fire can't alter global climate. Their technological conservatism, which seems like a limitation from our perspective, was actually a safety mechanism. They couldn't accidentally engineer their own extinction because they didn't have the tools to do so. Then there's environmental impact. We're currently causing the 6th mass extinction in Earth's history. Species are disappearing at rates 100 to 1,000 times higher than the background extinction rate. We've simplified ecosystems, reducing biodiversity, creating conditions where a single shock could cause cascading failures. We're changing the climate faster than most species can adapt, including ourselves potentially. Homo erectus lived within their environment's carrying capacity. They were predators, yes, and they probably drove some species to extinction locally, but they never altered planetary systems. They never pushed ecosystems to the breaking point. They survived for 2 million years precisely because they remained part of the natural order rather than trying to transcend it. This is the paradox. Everything that makes us seem advanced, dominant, successful in the short term might be making us vulnerable in the long term. We've created a civilization that requires continuous growth to sustain itself. We need constant technological advancement to solve the problems created by previous advances. We're running faster and faster, never able to stop, because stopping might mean collapse. Homo erectus walked slowly. They changed gradually. They endured. We're sprinting, changing rapidly, dominating completely. And we don't know yet whether our strategy is superior to theirs or just different. The test isn't how impressive we are right now. The test is whether we'll still be here in another 1,000,000 years, let alone 2 million. There's another angle to consider. Quality of life. Homo erectus lived hard lives by our standards. High infant mortality. Short lifespans for those who survived childhood. No medicine. No security beyond what the group could provide. Constant struggle for resources. But they also lived in stable social groups, in direct contact with nature, with clear purposes and roles. They weren't struggling with existential questions about meaning or dealing with the psychological stresses of modern life. Modern humans have longer lifespans, better healthcare, more material comfort, but we also have epidemic levels of anxiety, depression, loneliness. We've created societies so complex that individuals feel lost within them. We're more connected than ever through technology, but often feel more isolated. We have access to unlimited information but struggle to find wisdom. We've gained the world, but possibly lost something essential about what it means to be human. Is that success? Or is it a trade we made without fully considering the costs? Homo erectus never faced these questions because their lives remained fundamentally human scale. They lived in groups small enough that everyone knew everyone. They performed tasks that had immediate, visible results. They existed in direct relationship with their environment. They might have been materially poorer than us, but they might also have been psychologically healthier in ways we've forgotten. And there's the time horizon to consider. Homo erectus existed for 2 million years in a relatively steady state. Yes, they evolved. Yes, their tools improved. But the pace of change was slow enough that each generation lived lives recognizable to their ancestors. Culture was stable. Knowledge accumulated gradually. There was continuity across deep time. We've been in our current state of rapid change for maybe 200 years, since the Industrial Revolution. That's 1/10,000th of Erectus's run. We have no idea if this pace of change is sustainable over evolutionary timescales. We might be like a sprinter in the early stages of a marathon, burning through our reserves at a pace that feels exhilarating now, but might leave us collapsed and exhausted long before the finish line. So who was more successful? The species that endured for 2 million years, living within their ecological niche, maintaining stable populations, surviving countless crises through resilience and adaptability. Or the species that transformed the planet in 300,000 years, achieving unprecedented power and knowledge but also creating unprecedented vulnerabilities? We can't answer that question yet. We're still in the middle of our story. Homo erectus's story is complete. We can judge their success by the fact that they persisted for so long. Our story is ongoing. We won't know if our approach works until we've matched or exceeded their longevity, and we're only 15% of the way there. If we make it to 2 million years, then yes, we can claim success. If we transform ourselves into a spacefaring civilization, spreading to other worlds, ensuring our survival, even if Earth becomes uninhabitable, then we've achieved something Erectus never could, and our different strategy will have been vindicated. But if we collapse, if our civilization fails under the weight of its own complexity, if climate change or nuclear war or some unforeseen consequence of our power ends us prematurely, then history will judge us as the species that burned bright and brief. Homo erectus never asked these questions because they didn't need to. They existed within their environment, part of the natural cycles, neither dominant nor dominated but simply persistent. They were the most successful human species in the way that matters most in evolution. They lasted. We've chosen a different path. A path of transformation rather than persistence, of dominance rather than integration, of rapid change rather than gradual evolution. It's made us powerful beyond anything previous humans achieved. But it hasn't yet made us successful, in the only measure that ultimately matters, and that's the paradox we live with. We're simultaneously the most impressive and the most precarious human species, the most advanced and potentially the most doomed, the most knowledgeable about our world and the most uncertain about our future. We've achieved incredible things in a cosmically brief span of time, but we haven't yet proven we can endure. Homo erectus survived for 2 million years. We've survived for 300,000. The question isn't which number is more impressive. The question is whether our 300,000 will stretch to match their 2 million. Whether our different strategy, our rapid innovation, our environmental transformation, our technological power represents a sustainable path to long-term survival, or just a different way of eventually failing. We won't know for thousands, maybe millions of years, and that's perhaps the most humbling realization of all. Despite our power, despite our knowledge, despite our seeming dominance over nature, we can't know if our choices will lead to endurance or extinction. We're conducting an experiment with ourselves as the subjects, and the results won't be clear until long after everyone alive today is dust. So, as you drift off to sleep tonight, think about those 2 million years. Think about the countless generations of Homo erectus, living their lives in ways we barely understand, surviving crises we can barely imagine, persisting through deep time in ways we haven't yet matched. They were the original survivors, the species that proved humans could last, and we're still trying to prove we're their equals. 300,000 years down, 1,700,000 to go until we match their record. Let's hope we're wise enough to make it. Because if there's one thing this story teaches us, it's that success isn't about how impressive you are in the moment. It's about whether you're still here when the moment ends. Sleep well. And if you enjoyed this journey through prehistory, through the gaps in time that separate us from our ancient relatives, hit subscribe. Leave a comment about where in the world you are right now, what time it is, whether this made you think differently about what it means to be human. Because we're all part of this ongoing experiment in survival. All descendants of the species that outlasted everyone else. All hoping that our bet on rapid change and technological power will prove as sustainable as Erectus's bet on slow evolution and environmental integration. We're the last humans, the only survivors. And we're still figuring out if that makes us winners, or just the last ones standing before the music stops. But let's push this question even further, because it deserves deeper examination. Or is it about something more complex, more nuanced? Consider this. A species that exists for 10 million years but has minimal impact on its environment, that occupies a small niche and affects little beyond itself. Is that more successful than a species that exists for 1 million years but fundamentally reshapes the biosphere, creates new ecological patterns, leaves a mark that persists long after it's gone? Homo erectus took the first approach. They endured. They persisted. They maintained a steady state for an almost incomprehensible span of time. But when they finally went extinct, the world continued largely unchanged. Their tools became fossils. Their camps eroded away. Within a few thousand years of their disappearance, it was as if they'd never been there. The ecosystems they'd lived in adjusted and moved on. Homo sapiens is taking the second approach. We've been here for 300,000 years, just 15% of Erectus's run. But we've already transformed the planet in ways that will be visible for millions of years. We've altered atmospheric chemistry. We've changed global temperatures. We've caused an extinction event that will show up as a distinct layer in the fossil record. We've scattered radioactive isotopes across the globe. We've created materials that will persist for thousands of years. We've even left trash on the moon and sent probes beyond the solar system. If we went extinct tomorrow, if some catastrophe wiped out humanity entirely, our impact would still be visible to alien paleontologists studying Earth 1 million years from now. They'd see a distinct boundary in the rock record. Before, after, impoverished fauna, chemical anomalies, geological signatures of rapid change. They'd know something dramatic happened, even if they couldn't determine exactly what. Is that success? Or is it the signature of a species that burned too bright, changed too fast, pushed too hard? The answer probably depends on what happens next. If we manage to stabilize, if we find a way to live sustainably while maintaining our technological capabilities, if we spread to other worlds and ensure our survival, even if Earth becomes uninhabitable, our approach will have been vindicated. We'll have proved that rapid change and environmental transformation can be compatible with long-term survival. But if we collapse, if our civilization fails under the weight of climate change or resource depletion, or some other consequence of our rapid growth, if we go extinct having lasted less than 500,000 years, then future scientists, alien or evolved from whatever species inherits Earth after us, they'll see us as a cautionary tale, the species that could have been great but destroyed itself through its own success. And here's what really should humble us. We don't get to write this conclusion. We're living in the middle chapters of the human story. We can see how it's gone so far, but we can't know how it ends. Homo erectus's story is complete. We can measure their success objectively. 2 million years, 3 continents, countless generations living lives we can barely imagine. They passed the test. They endured. Our test is still ongoing. Every day we exist is another day added to our total. Every generation that survives is another generation closer to matching Erectus's record. But every day we also accumulate more risks, create more vulnerabilities, push further into territory that no species has navigated before. We're innovating faster than evolution can test whether our innovations are sustainable. We're running an experiment with one trial and no control group. The paradox of human success isn't just that we're impressive but untested. It's that our very impressiveness might be what prevents us from enduring. The same traits that let us dominate the planet, our innovation, our ability to transform our environment, our capacity for rapid change, these might be the traits that prevent us from achieving the kind of long-term stability that characterized Homo erectus. Maybe there's a trade-off built into human evolution. You can have stable, sustainable existence across deep time, or you can have rapid innovation and environmental transformation. But maybe you can't have both. Maybe the species that lasts 2 million years is fundamentally different from the species that builds civilizations and reaches for the stars. Maybe Erectus and Sapiens represent two different strategies, two different answers to the question of what humans can be. And maybe only one of these strategies is compatible with truly long-term survival. If that's true, if there's an inherent conflict between innovation and endurance, between transformation and stability, then the fact that we've only lasted 300,000 years isn't just a historical detail. It's a warning, a sign that our particular approach to being human might have a built-in expiration date that we're rapidly approaching, or maybe not. Maybe we'll figure out how to maintain our capacity for innovation while achieving the kind of ecological stability that Erectus had. Maybe we'll learn to transform ourselves rather than our environment, using our technology to adapt to Earth rather than forcing Earth to adapt to us. Maybe we'll spread across the galaxy and achieve a different kind of success, one measured not in years but in influence, not in endurance but in impact. We don't know yet. We can't know. The story isn't finished. We can still choose which path to follow, which type of success to pursue. We can learn from Homo erectus's example, embrace the strategies that let them endure, accept the limits that kept them sustainable. Or we can continue on our current trajectory, betting that our intelligence is sufficient to solve any problem our innovation creates, that our technology will always stay one step ahead of the disasters we cause. Either way, future generations will judge us by one simple measure. Did we last? Not how impressive were our achievements, not how advanced was our technology, not how much we transformed the world. Just, did we endure? Did we prove that Homo sapiens could match or exceed Homo erectus's 2 million year run? Did we show that rapid innovation and environmental dominance are compatible with long-term survival? 300,000 years down. 1,700,000 to go. The clock is ticking. And every day, we're writing the next page of a story whose ending we cannot yet see. Sleep well. Dream of deep time. And remember that success, in the end, is measured not in moments, but in millennia. The story of these two human species, separated by nearly 2 million years of evolution, tells us something profound about what it means to be successful as a life form on Earth. It reminds us that there are many ways to measure achievement, many definitions of what constitutes winning the evolutionary lottery. And it challenges us to think carefully about which kind of success we're aiming for, and whether the path we're on will actually get us there. As you close your eyes tonight, let these timescales wash over you. 2 million years, 300,000 years. Numbers so large they become abstract, yet they represent real lives, real struggles, real triumphs of survival against impossible odds. Every Homo erectus who ever lived faced the same fundamental challenges we do: finding food, staying safe, raising children, making it through another day. They did it without any of our advantages, and they did it for 6 times longer than we've managed so far. That's not just impressive, that's the very definition of evolutionary success. And it's a standard we're still struggling to meet, despite all our technological prowess and supposed wisdom.